So this is Algebra 2 at Trig, Unit 5C.1. We're going to solve radical equations. With step 1, we're going to isolate the radical on one side of the equation. That means, like letter A down here, we have the radical on one side of the equal sign without any other extra pieces. Same thing with B. But with letter C, you notice that there's a +1 in addition to the radical, outside of the radical. That's not isolated. We would need to move the 1 first to isolate the radical. Then we're going to raise each side of the equation to the same degree, or the same power, if you want to call it that. Then we're going to solve the polynomial. So we come down to our first example. We see that the radical is already isolated. We recognize that this is a cubed root. So we are going to have to cube both sides of the equal sign. So when you cube a cube root, you get the value that's inside. And when you cube 3, 3 times 3 times 3 is 27. Then from here, the rest of it's pretty simple. This is why we took Algebra 1, so we could solve an equation. And we see we get the answer of -2. When you plug -2 in, -11 times -2 would give you a positive 22, plus the 5, 27 cubed. Cube root is 3. So you can check your work by plugging your number back in. We do want to check for extraneous solutions, and that's going to happen more when you have an x on both sides of the equal sign. This next one is a radical. It's a square root type of radical. So we are going to square both sides of our equal sign. Notice that when you square your square root, you get the value that's inside. You do not need to use FOIL if it was inside the radical. The square and the radical cross off. And you plug 3 back in, you get 3 plus 6 is 9. The square root of 9 is 3. Now this has the radical and it has a +1. So the radical is not isolated yet. We need to isolate the radical. So that means you need to move the 1 over first. That's the cubed root of x minus 5. And that's going to equal -2. Remember, a cubed root can equal a negative number. That's okay. A squared root is not allowed to equal a negative. That would be no solution. But a cubed root can. So we're going to cube the cubed root. We've got to use parentheses to cube a -2. When you cube a cube root, you get the value that's inside. Cube -2, you get -8. Simply add the 5 to the other side. You get -3. By plugging in -3, we get -3 minus 5, which is -8. The cubed root of that is -2. Plus 1 is a -1. All right, so these you're going to try on your own. Pause the video. Try this one, and I'll let you try that one. See what's the difference, then we'll work through it, then you can try another one just like it. We have a cubed root, so we have to cube both sides. When it's just a positive number, there's no need for the parentheses, but if it's a negative number, we need to have parentheses. So we have 6x minus 10 equals 8, because 2 times 2 times 2 is not 6. Common mistake is 6. So we're adding 10 across. So 6x equals 18. Divide by 6, and x equals 3. We can plug that in to get 18 minus 10, which is 8. Cube root of 8 is 2. Works out great. Letter D is a little trickier. The radical is already isolated. So we are going to square both sides of the equal sign. Now, when you square a binomial, we all know that you cannot distribute that through. You have to write the x minus 2 twice. The value that's inside the radical does not have to be FOILed together. It's just x plus 10. Whenever you square a square root, you get the value that's inside. When we FOIL here, we're going to get x squared minus 4x plus 4. And we can collect our like terms. Notice that we have two different types of x's. We have an x squared and an x. That gives us a reminder that we need to set one side equal to 0 and move everything else over. This is a quadratic, so we're going to solve the quadratic by factoring. If we were going to use 2 and 3, they would both have to be the same sign to get up to negative 5. But because the 6 is negative, we know the signs have to be opposites. So this is going to have to be 6 and 1. A negative 6 and a positive 1 will add together to be negative 5. Then we can use the zero product property to help us calculate that we get 6 and we get negative 1. Now, checking for extraneous solutions, when we put a negative 1 in for x over here, we get negative 1 minus 2 is negative 3. We have a negative 3 on this side. Can a square root, no matter what the x is, can a square root equal a negative result? And the answer to that is no. You can plug negative 1 into here and you get 9. The square root of 9 is 3. So 3 does not equal negative 3. This would be considered extraneous. Not because the x was negative, but when you plugged it in, we have a square root equaling a negative. When we plug in 6, 6 minus 2 is 4. Plug in 6, you get 16. Square root of 16 is 4. Remember, you only get plus or minus when you do it to both sides of an equal sign. So you go ahead and try the next you try. You can pause the video, try it out, come back, and see how you did. So, of course, we're going to square both sides because we're working with a square root. That gives us x plus 2, and that has to be written twice. You cannot distribute it. That gives us 2x plus 7, because you square a square root, you get what's inside. This would be x squared plus 4x plus 4. we would subtract over or collect our like terms. That makes 0 on one side. For positive 4 minus 2 gives us a positive 2x minus 3, which can be factored. And then we use the zero product property to set up a negative 3 for x and a positive 1 for x. When we plug in the negative 3, we see that that would give us a negative 1 on one side of the equal sign and a radical square root actually on the other. So that's going to make this an extraneous solution. So we only circle the 1. If this was a multiple choice test and it's asking for the real solutions, you would only bubble in the answer for 1. You would not include the negative 3 because the extraneous solution is not a real solution. All right, for our next section down here, we would need to add the 21 first because we're trying to isolate our x value. We don't have a radical right in front of us, but we're trying to isolate that x value that has the fractional exponent. Then we will divide by the negative 2. It is super important that you move the 2 first. Now, we have a tendency to want to write this using radicals, the cubed root to the 4th power. I would suggest to keep it as a fractional exponent because we're going to take the 4/3 and we're going to raise it to the power of 3/4 because that gives us 12 over 12, which is a value of 1. So x to the 1st power. And what we do to one side, we also have to do to the other side. So this is really going to be 16 to the 1/4 power cubed. Now notice that we took an even radical to both sides. So 1/4, when we're talking about a radical, the 4th root of 16 is 2. So we're going to have to call this plus or minus 2. And when we cube plus or minus 2, we are going to get a plus or minus 8 as an answer. And if you wanted to take the time to plug it in, we're plugging in negative 8, remember. Negative 2 times negative 8 to the 4/3 power minus 21. That gave us the negative 53. Or if we plug it in as a positive 8, we also get negative 53. So you can plug in your values to check your work to see how you did. At least in your homework, you know your calculator is available to you. Here we have to isolate what would make a radical. So we have to move the 2 over first. So this is x minus 1 to the 2/3 equals 4. We see our exponent is 2/3. So we're going to raise it to the power of 3/2. And if you do that to one side, you have to also do that to the other side. Which means that you're actually taking the square root of 4. The square root of 4 is 2. Cubed is 8. But you're going to get plus or minus 2. When you do that. So you're going to have x minus 1 equals plus or minus 8. X minus 1 equals 8. And x minus 1 equals negative 8. When you add your 1, you get 9. And when you add your 1, you get negative 7. So let's plug in our numbers and see how they did. When you plug in 9, 9 minus 1 is 8. The cubed root of 8 is 2. Squared would be 4. Plus 2 more is 6. Negative 7 minus 1 is negative 8. Cubed root is negative 2. Squared is positive 4. Plus 2 is 6. So those are both solutions. And notice you have an x value that's negative. That is okay. So letter C, we want to isolate the x value, so we have to divide first. So that's x to the 3/4 power equals 8. So we're going to raise it to the 4/3 power. Now notice we're raising it to the 4/3. That's the cubed root. When you do the cubed root of 8, you only get 2. You don't get plus or minus 2. To the 4th power is 8. What I did was skip a step in here, but what I did, I took my 8 to the 1/3 power, and then I raised that to the 4th power. I broke up my 4/3 into 8 to the 1/3. I got my 2. Then I raised that to the 4th power to get 16. All right, on the flip side. We have some power consumption. The amount of power used by an appliance is given by this crazy formula, where I is the current in amps, and R is the resistance in ohms, and P is the power in watts. If the appliance uses 12 amps for the I, for the current, and the resistance is 12, or actually 25. That goes on the bottom of the square root. And the power is P. We want to know what does the power. We have one variable. So a couple ways you could do this. You could take the square root of the top and square root of the bottom. That would totally work. That might be more reasonable for you. So we'll take 12 equals the square root of P over the square root of 25. So that is 12 equals the square root of P over 5. So now we're going to times both sides by 5 to get 60 equals the square root of P. And remember, to get rid of a square root, you want to, or you need to, square it. That's going to give you 3,600. And we're solving for P. And P is watts. So using this formula and these new numbers down here, I is 10, P is 200, solve for your resistance in ohms. Pause the video, give it a try, come back and see how you did. So we're going to set up our problem using our formula. We know our I is 10, our P is 2,000, and we're solving, find R. So last time I broke it up into two radicals because I knew the square root of one of them. Here, I'm going to square both sides, which gives me 100. Then with R being in the denominator, I'm going to multiply both sides by R. And when you divide by 100, you're left with 20. And those would be ohms. Okay, let's finish everything up with you practicing 4A and 4B, and I'll work through it also. So pause the video, come back and take a look. This first one, the radical is isolated already, so we're going to square both sides. That's going to produce two binomials that have to multiply each other. So we have to bring them all over to the same side. That's x squared plus 9x plus 14. That's going to leave us with an x plus 7 and an x plus 2. That's going to give us a negative 7 and a negative 2. Now typically we recognize that when x is negative, that is usually a concern. Plug in negative 7. Negative 7 plus 5 gives us a negative 2 answer, and a radical cannot equal a negative answer. So you know that this one is extraneous. When you plug in the negative 2, you have a larger plus 5. Negative 2 plus 5 is a positive 3. That's okay to have. Plug in the negative 2 under the radical and you get 9. Square root of 9 is 3, so that's why it matches. Negative 2 is your answer. And on the last one, when you move the 8 over, we get a negative 2 on one side of the equal sign. The radical, the square root, specifically, equals a negative. A cubed root can equal a negative. A square root cannot. So this has no real solutions.